The vast expanse of galaxies in our universe never ceases to fascinate us. Welcome to another episode of Planetarium, where we delve into the captivating world of space beyond our planet. In today's video, we will explore the Andromeda Galaxy and the enigma scientists have recently uncovered within it. Previously referred to as Andromeda Nebula and Messier 31, the Andromeda Galaxy is a barred spiral galaxy and the closest known galaxy to our Milky Way. Its name derives from Greek mythology, specifically the wife of Perseus, and is visible to the naked eye from Earth. Scientists have been studying this galaxy for some time, and their latest discovery has intrigued many astronomers. A gas cloud was recently found near Andromeda, and its origin remains a mystery. Interestingly, it was discovered that the cloud had been in plain sight for decades, yet we had no knowledge of its existence until now. Significant investment has been made in developing advanced telescopes and digital detectors to capture images of space and its celestial bodies. Consequently, astronomy enthusiasts often engage in astrophotography, which has led to the discovery of new celestial objects, contributing immensely to the field of astronomy. Recently, amateur astronomers and researchers Marcel Drechsler and Javier Strottner used state-of-the-art technology to scan various sections of the sky, hoping to make a new discovery. They were particularly interested in locating faint nebulae or gas clouds and enlisted the help of French astronomer and astrophotographer Jan Sainty. Jan Sainty determined that targeting Andromeda and searching for nebulae would be the most prudent course of action. Given that Andromeda is a galaxy similar to our Milky Way, investigating it made logical sense. This vast spiral galaxy is just 2.5 million light-years from Earth, making it an easily observable target. As a result of its close proximity, astronomers have been studying Andromeda for over a century. Since most of the galaxy's regions have already been studied, astronomers presumed that any new discoveries would be insignificant or small. Little did they anticipate making any groundbreaking discoveries. Jan Sainty shared his observations with Drechsler and Strottner, who processed and analyzed the images. During their analysis, the amateur astronomers made a significant discovery: a colossal structure adjacent to Andromeda. Interestingly, the nebula was only visible in the images. Jan took using a filter that blocks all light except those that emits a blue-green glow caused by doubly ionized oxygen. This glow is produced when oxygen atoms lose their outer electrons. Moreover, Jan used a filter which was tuned to the light from hydrogen atoms. The results obtained from images taken with this filter indicated that the oxygen-rich nebula stood out significantly from the gas clouds surrounding Andromeda. The astronomers initially suspected that their unique cloud could have been an image capture error, such as reflected light in the telescope. To confirm its existence, the three astronomers enlisted the help of astronomer Bray Falls, who observed the nebula using his telescope and confirmed its presence. Subsequently, more experienced astronomers were brought in to verify the discovery. Observations from 5 telescopes in France, California, and New Mexico confirmed the cloud's reality. The cloud was named Strottner-Drechsler-Sainty Object 1, SDSO-1, after its discoverers, Marcel Drechsler, Javier Strottner, and Jan Sainty. However, the object's identity remains a mystery. The only confirmed fact is its existence. As a result, the team of astronomers sought the expertise of Robert Fesson, Michael Schull, and Stefan Kimswenger to conduct a more in-depth analysis of the object. The fascinating findings resulting from the study of this object were published in the research notes of the American Astronomical Society's journal, with due credit given to the professional-amateur collaborations. The cloud's close proximity to Andromeda has led experts to believe it may have a close relationship with the galaxy. It has a distinct curvature that bulges away from the universe and spans tens of thousands of light-years, making it one of the galaxy's most extensive, coherent structures. The cloud is located within the halo of Andromeda, a spherical cluster of stars surrounding the galaxy. Some experts speculate that the cloud was formed by gas emitted by the galaxy's many stars. However, this theory is contradicted by the fact that a significant hydrogen component, abundant in stars, was not detected in the cloud using the filter used by Jan to capture the images. These findings could potentially reveal the mystery of the cloud's origin. As Andromeda moves towards the Milky Way, SDSO1 is located between the two galaxies. This has led many astronomers to speculate that the two galaxies' halos may interact, leading to the formation of the cloud-like structure. One theory suggests that the gases present in the halos of the two galaxies diffuse and compress upon collision, forming a curved structure. However, if this were the case, the structure would not appear as close to Andromeda as it does now, and it would exist somewhere between Andromeda and the center of the Milky Way. Additionally, the lack of hydrogen in the cloud remains a mystery. Another possible explanation is that SDSO1 could be a planetary nebula in the Milky Way closer to Andromeda. Planetary nebulae are shells of gas shed by dying sun-like stars, typically rich in hydrogen and oxygen. The central star provides energy to the gas, making the nebula appear brighter. However, this raises the question of whether or not hydrogen is present in SDSO1. SDSO1 could be the remnant of a Milky Way star that exploded as a supernova. However, this would mean that the object should radiate ultraviolet light and radio waves, neither of which have been observed in Andromeda's past data. The object also did not emit X-rays or infrared light. SDSO1 is approximately the size of 3 moons, making it challenging to observe with larger telescopes with a narrow field of view. Furthermore, despite its size, the object is very faint, requiring 160 hours of observation and a doubly ionized oxygen filter to capture an image. Even the Canada-France-Hawaii telescope, equipped with a 378-megapixel camera, could not capture the object, despite observing the same section of the sky for an extended period. To unravel the mystery of SDSO1, the cloud's light must be broken down into small wavelength parts to determine the velocity of the gas via the Doppler effect. If the cloud moves at the same speed as Andromeda, it is most likely a part of that galaxy. However, if it is moving slowly, it is more likely a part of our Milky Way. If the gas moves towards us, it emits a blue shift shade, while if it moves away, it radiates a red shift shade. What are your thoughts on the SDSO1? Do you think it is part of the Andromeda Galaxy or the Milky Way? If you like this video, please give it a thumbs up and subscribe to our channel for more videos just like this. And we'll see you in the next one.